I'm going to talk about the how much the current software, SaaS platforms, browser and device farm platform are in alignment with best practices in software industry. So the agenda is going to be, I'm going to look at the key ingredients of CI/CD pipeline, then look into the current problems in the browser and device farm SaaS platforms, new use cases contributing to the problem. So, the problem is kind of increasing and it's supporting that there is a problem, and evolution of supporting technologies, which says, hey, yeah, these are problems, but there are new technologies that could fix this. And some of the disappearing outliers that has been a big challenge in cross-browser device automation in the past, and how to test smart. So this is what's going to be the agenda. Key ingredients of a CI/CD pipeline, right? So if you look at any software company, like any company in the world, everyone is trying to fine-tune the how you can take a code change from your commit to production faster with quality. That's what everyone is trying to do. If you look at any other tool that is around this ecosystem, monitoring, logging, everything, is to augment that concept when you're not doing things right with your change, right? That's a key fundamental of any software engineering company. So what are the key ingredients of a pipeline is run test frequently, which means you fail often, and focused micro tests. You don't go and write more UI tests. Start with unit tests, start with integration tests. Test fast, which means, run your tests concurrently, which means you can test fast. So this and fail often are linked. If you can't test fast, you can't fail often. If your test takes 1 hour to run, then you're not going to fail often. You're going to fail slow, right? And run critical tests first, which means fail fast, which means you write, say, smoke test or any critical test, and if they fail, you immediately know. And the other one is shift left. Run whether you fail often or whether you fail fast or whether you test fast. Make sure you run them closer to the code, and that's shift left. And in the middle is the visualized test results. It means you might be running 15 times a day all your tests and all your automation, but unless you have a proper way to bubble up real issues, nobody has the time to look at every time what something fails, right? So the proper visualization is also an important key ingredient. So the reason I showed you the key ingredient slide is to make sure that how that is in alignment with the current business model of SaaS platform, cross-browser platforms. So one of the problem in current browser and device platform is cost is based on the number of parallel connections. So for example, if you go to any SaaS platform, they will charge you based on how many parallel connections you need. Across your organization, you might have 15 or 20 or 100 teams, and your cost is going to increase based on how many parallel connections you want to buy, and it's very expensive. So if you buy 100, it means across your organization you can only run 100 tests concurrently. So the cost decides your productivity, how fast your changes reach production, right? So now we talked about fail fast, run concurrently. Those concepts are not, this type of a model is not alignment with some of the key concepts. The second one is fixed cost, not based on actual usage. You pay something, whether you use it or not, you're going to, you're not getting the money back. For example, during COVID, I know lots of big companies didn't make even a single dollar. And for them to keep paying when they're not using, then when they're not making money, it doesn't make any sense, right? Why can't it be like pay as you go or something like that? So you pay regardless of usage. Imagine if you have a system where I can see how much exact precise dollar cost for running one suite of automation, and I can see the figure, say it cost me $5. That will be brilliant. I can estimate for week, for month, for year, and I know how fast I could run, and make sure that I'm running everything in a cost efficient way. So that's the second part. The third is not suitable for shift left use cases. So normally people check in or merge a pull request, and then automation runs, and it goes in a sequence fashion, so other people have to wait. But when it comes to shift left, you're not just running after you merge your pull request, but you're going to run for every one of your branches. We will show you some of the slides later. I'll show you some of the slides later. So that means the number of the frequency of your tests and the concurrency of your tests is going to increase. So not just testing after change or merge run, but for every commit to branch. So this is going to increase the number of tests you run concurrently across the organization. It's going to increase that. So this is another problem, because it's going to increase your cost with the current model. The other one is lack of expertise in QE engineering, quality engineering, to build scalable automation infrastructure. Often it is normally is the last organization to look at in terms of investing money or anything. So because of lack of expertise, people still use primitive ways like running Selenium grid in your data center, still depending on data center where you cannot scale, and still go slow. Like I still hear people running hours of automation overnight to cover things, and it's still surprising to me. And well, I'm not surprised. I know that the investment in QE engineering, quality engineering, is really, really low. So that's another problem. And why it's happening is because of cost and also lack of expertise. Now, if you ask me 10 years ago, applications were released. It's very normal, which I have personally seen, for an application to be released to production once in 6 months, right? It's very normal. I have seen it. But it's no longer the case. Whatever was monolith application is becoming micro frontend, and what you see here is each section, behind each section could be a micro frontend that's powering. If you click sign in, that might be a separate application, but for user, it's just one application. So the way I'm looking at is between each section, there's a CI/CD pipeline, and between each section, there's a CI/CD pipeline, there's a team, say average 5 people, and when they merge, CI/CD pipeline runs, and on average, if I say each pipeline has 30 tests, across the 50 teams, it's going to be 1,500 tests. Of course, not every pipeline is going to run at the same time. Even if I say 1/3 of the test runs, it requires around 500 tests, which means I might need around 400 parallel connections, right? And current billing model, current business model, that's very expensive. That's not the end of the story, right? So if you look at this is from National Institute of Standards and Technology from US Department of Commerce. It clearly says that, when you want to fix something, when you are coding, it's very cheaper to do. Shift left, when you do things closer to code, it's cheaper to fix things. But when you go to the right, especially in production, it's going to cost you a lot of money for fixing. Lots of people have to be involved. Not only that, you're going to lose money by broken features. So what can we do to solve that problem is, for example, instead of running your tests for after you merge your pull request, you could actually deploy your branch, your temporary stack, say in Kubernetes, and run your tests and make sure for every commit you can run and make sure that when you merge, your change is production ready. And for the same case I showed you before, but now with shift left, across the organization, you might be requiring around 7,500. But again, even if you take 1/3 of this, if you need to have that many parallel connection, you should have both that many parallel connection from SaaS platforms, and definitely it's going to be costing you millions of dollars, right? And nobody's going to approve that amount of a budget for test automation. So these are some of the challenges that we have currently. And this is another way to look at, for example, you branch out, you deploy, you test. So every branch can have its own temporary stack, temporary pipeline run, and you destroy it, right? So this is with a Kubernetes-based Selenium Grid solution. Now, another problem is the fully dependent on expensive real devices. If you look at most of the platforms, there's no other choice. You have to use real devices. But if you ask, do you have to run all your test automation on real devices? Do you have to run everything on real devices? Probably not. So this is one of the reason the license model and the parallel connection model are expensive, because they are going for expensive way of doing things. It's going to end up being expensive for consumers. Cloud-based data center, that's another problem where these companies they mostly rely on data center for stacks of real devices and VM machines and VMs for browsers and other things, and it's not going to be really scalable, just like that, because you are not on cloud. And if you, as opposed to if you're on cloud, that's a different story. So this is another reason for the current non-sync between the SaaS platforms, browsers platforms, and the key ingredients of software engineering, the CI/CD pipeline. So now we looked at what are the current problem in the SaaS platform, cross-browser and device SaaS platforms. What are the new use cases that are contributing to this problem? New emerging use cases. So one thing you might have observed, or you might have probably not seen it, but if you go to Facebook and if you see an ad, or if somebody posts a link and if you click, it's not going to take you to a different browser. It's going to open it in something called an in-app browser, right? And what is an in-app browser is the Facebook or LinkedIn or any other website. They don't want you to leave their realm so that they can keep track you and bring you back immediately. So this in-app browser is nothing but it's a primitive, I think, Safari or Chrome. But I just took a quick check. Hey, can I go to a checkout page in in-app browser? So this is an in-app browser in Facebook. I was able to go all the way up to the checkout page. And statistics shows that people using in-app browser is increasing, because normal people, they don't know how to go to the settings and change so that it actually opens in a real browser. So what I did was, just to check, I opened my Gmail on a normal browser and in-app browser, and you can see how it looks. It means that there's a potential that it could be broken. Your website, you might have tested in every browser, but it might be broken in an in-app browser. How are you going to test it? It's a big challenge, because it is actually a Facebook or LinkedIn app that is going to show your browser, so your website, right? So this is another challenge. The other challenge is we might think that the traffic on mobile or mobile devices, or they are increasing, so we can actually change the coverage on mobile instead of desktop. But if you look at the statistics, the conversion is still high on real device desktop browsers compared to mobile. So global mobile conversion rate were at 1.81% with desktop at 1.98, right? Which means even though traffic is high on mobile, you still have to, your coverage should be more on desktop, because that's where it converts more. It brings you more memory, more money, right? So you still have to test on mobile web and native apps and other things, but at the same time, you still have to increase your coverage on your desktop browsers and different versions. So this also, the message is, you can't relax on your desktop browser test automation. You have to increase it. And this also support the argument where Chrome, Firefox, Edge are releasing roughly every 5 weeks. And personally, if you look at your company user omniture, what browsers they're using, most of the time you could see that 80% of customers are either on the latest version or latest -1. And the rest of the 20 or so percentage of people are on the next 2-3 versions. So this might, sometimes if it is really sensitive site, you might need to, run on latest and latest -1 as well, because all the time, majority of customers are shifted on latest and latest -1. And so the next use case, next problem that is contributing to the problem, next use case is there's a shift. In the past, what a company's revenue, it will be majority of the revenue will be from US, right? But that is changing. It's not the revenue is decreasing in US, but the other countries are developing and their standard of living is increasing, and that because of that, the non-US income is now more than the US revenue in most of the companies, which means like companies like, for example, countries like Vietnam, they have their own browser called Coco. It is Chromium based, but it is slightly customized. In India and China, UC browser is second popular. And Indonesia, UC browser, it's also Chromium based. Yandex browser in Russia, I think that is also Chromium based. But the pattern is, it's a matter of time that somebody might think like, oh, why don't we create a new browser? And it is happening. This is China web browser market. You can see that there are so many other browsers competing here. And if you look at the mobile one, Chrome is 8%. So this is a pattern where we have to anticipate and expect what's going to happen next. Is a new browser is going to come up, or do we have to test on different browsers, right? So these are new use cases. But also, if you look at, hey, there's not going to be any new browser, but there is going to be a new browser. Even though Vivaldi and Brave are Chromium based, there's a new browser called Flow, but it's only available in Raspberry Pi right now, but it's not on a normal desktop browsers. But again, this is a pattern. It is happening, right? So somebody is creating a new browser, even in this day and age, when we think things are converging and everything is moving towards Chromium. The next one is metaverse. So I don't know if you watch Mark Zuckerberg video. It's a 1 hour long or so video, and it was really exciting to see what's coming in the future. I'm going to read what stood out for me when I was watching it. You're going to be able to bring things from physical world to metaverse, any type of media, digitally, photos, videos, art, movies, music, books, games. A lot of things that are physical screen today will be able to be holograms in the future. You don't need a physical TV. You just need a hologram projector. You're going to be able to do this on all kinds of devices. New ways of interacting with devices. Instead of typing or tapping, you're going to gesture with your hands. This could change the way we are interacting. Probably even web browser could become a thing of past. For example, if you are browsing for booking a hotel, right now you go to browser, go to the site, search for a location, and then you browse through and look. What metaverse is going to do is, you probably don't need a browser. You need to have a virtual like a specs or a projector, and you will be in the hotel. You can actually see the room or whatever room type you're going to see in 3D. You can flip, you can go in and see how it looks. You can see the view, and you can flip and go to the next room or the next hotel, and then pay everything on 3D. Right. So this is this is happening. It's not theory. It's happening in 3-4 years. This will be a phenomenon, probably even before that, if somebody is really going to try that. Imagine how this is going to be in a native app, how this is going to happen on a mobile web for a e-commerce business. This is a huge potential, and we have to think ahead how to solve this in terms of test automation and quality. So far we have seen what is the current problem, what is the new use cases contributing to the problem, and what I'm going to show you is evolution of new technologies that could help us solve this problem, because of the how we can scale browsers in a cost-effective manner, iOS and Android devices. AWS bare metal instance allows you to run Android at scale. AWS Windows allows you to run Windows browsers, for example. This is not new, it's been there for a long time. Sorry. And the other one is AWS has released EC2 Mac instances called Mac One Metal. Even though right now, as far as I know, there's no solution to run Mac as a Kubernetes worker node. I'm sure somebody is working on, and that will be a thing of past soon. There are lots of Mac Mini Cloud, which is like AWS for Mac Mini Cloud, Mac Minis. And also a company called Mac Stadium, they have a proprietary solution, Orca, for running OS X as a worker node on Kubernetes. This will change things, where it will bring down costs, it will help you scale devices and emulators and simulators and browsers at scale. That's not only that, there is a new technology where it's bringing the both world of VM and container, and where you can actually select. Imagine you have a container with the Linux Ubuntu image, and it's going to be, say, Selenium hub image is going to be like 3 GB, right? With this, you can selectively say, hey, I'm going to do some browser testing. I don't need XYZ modules in this operating system. I'm going to remove that, and I'm going to reduce the size of the image to 300 MB, and that's possible. And when you reduce the size, everything's going to be much faster, right? So these are new technologies that are emerging for solving this problem. The disappearing outliers is basically, one of the first reason why people have to have cross-browser platform initially was IE. IE is the outlier, right? It is different to compare to other browsers. But now IE 11, the support is ending on June 15, 2022. And MS Edge legacy already ended, and it's already moved to Edge. And if you look at the statistics of Microsoft browsers, Edge is the Chromium-based Edge is the majority, like probably 90% or more than that, what customers are using. So the outlier is gone, is actually gone. So it's make things a bit easier for us. So now we talked about the problem of scaling and the cost of the current SaaS platform. How can we scale in a cheaper way, not just browsers, but devices and emulators and simulators? At the same time, how can you test smart? Do you have to test a change on everything, right? So imagine there's a change, code change, and of course, testing never ends. Testing never ends, it only stops. You cannot run everything on every operating system and every browser and every browser versions, and we don't have all the time in the world to go and check everything. It's never going to happen. That's why nobody, sometimes people don't rely on automation, because unnecessarily we run on too many things. We're not, being smart. We're not doing tests in a smarter way. So what I thought was, like, in maths, you might have studied about mathematical induction proves that, we can climb as high as we like on a ladder by proving that we can climb onto one bottom rung and not worry about the rest, but just prove I can go to the step one. And then from each rung, we can climb up to the next one. So the base case is prove a statement for n equal to 0. So in our case, the way I look at and guide our teams is first make sure your change is working. Whatever code change you made, make sure that code is working. Don't worry about it's working on every browser. You don't even have to worry about it. Is your change is working on one of the highest grossing browser for you? Is it working? Your change is working. That's half the story is finished. Then take a subset of your case test and run it on your top 5 or 10 browsers, so that you are sure that your change is working. But if it fails, then it's something to do with the browser specific things, and then you can look into that. So first, is your code change is working? No, don't worry about the browser. Then you don't have to run the same cases on every browser. Just pick few, probably 5% of your critical cases and run on your other browsers. So that is I think the best way to make sure that you have enough coverage. At the same time, you are being really smart about it in terms of cost, time, and time spent on analyzing things. So this is another way to look at it. I said I put Chrome here because mostly Chrome is the highest used browser, but it could be any browser based on your website, based on your use cases. Then you can use Chrome emulator for responsive test, because for just to make sure your site is responsive, all you have to do is make sure your page is showing what it's supposed to show at different breakpoint, and it's not showing what it's not supposed to show at certain breakpoint. You can easily do that in Chrome emulator. You don't need a real device for that, right? And then you run it on one of your top browsers, Edge, Firefox, and Safari. Run on iOS, emulator and simulator for certain things. Then you go to real device for, hey, if I open my site on Safari, is it crashing? Or I want to just make sure that I run it on real device. So a tiny amount of tests on real devices. And this is another way to look at the pyramid, is to cover based on the rendering engine. Blink, V8, Chrome, and Chrome emulator, Blink, V8, and other engines as well. So this is another way to say, hey, I'm running differently, but at the same time, I'm still covering all the rendering engines. So this is an infrastructure pyramid to achieve the scalability that what we are saying as a problem that the current providers and the software engineering, the key ingredients of CI/CD pipeline are not in sync. This infrastructure pyramid is to fix that problem, that you can run browsers at scale, that you can run devices, simulators and emulators at scale using this layers of technology. You can achieve that. So it's it can be a SaaS or on-premise product. Then you have cloud. It could be Google, Azure, or AWS, or Mac Cloud. Then you use an orchestration engine like Kubernetes. Then you use container platform. On top of it, Selenium or APM, others. We have Ingress. So you could have any number of grids, any number of grids running at any point in time across your organization. And so no one team is limited by how many tests they can run. Each team can run even 200. So across your organization, at any point, probably even thousands of tests are running at the same time. You don't have to worry about parallel connection, how much you have to buy, and all those things. So this is a way to show that you especially when you containerize and use an orchestration engine, everything is you create, you run your test, you destroy it. You create, you run your test, you destroy it. So you're only going to use resources for what you need, and not like something that's always ever running, which is not why we have cloud for. So I'm going to, this is the last slide. And what is the value addition normally a test automation infrastructure should give you? It should save money. A cost-effective automation solution helps you save money. Auto-scale infrastructure, so you only pay for what you use. pay only for what is used, minimum expense on cross-browser platform. So it helps you save money. It also helps you make money because it allows you to scale in an highly scalable, almost an unlimited with no restriction way. It allows you to go to production faster. With this, you could go to production with every change. You can go to production. You can go to production every 1 hour. You can go to production every half a day. Instead, if you don't have this, you might be going to production once a week or once in 2 weeks. That's going to cause more problem because you're accumulating your changes, and then when it goes to production, when something fails, then it's very difficult to debug. Very difficult to find who the problem is. So that will be interest to the business, but at the same time for developers or engineers, save time, because now your feedback cycle, how fast I can know my change has caused a problem or not, I can just know it in 10 minutes because I have the concurrency. I can spin up 100 browsers and run all the tests in like 2 minutes. So saving time, I did a math where if you have, say, 5 applications and there are 7,000 pull requests in 1 year, if you save 4.5 hours in one pull request, in 1 year for the 7,000 pull requests, that is equal to 14 engineers working the entire year taken out. Imagine 14 engineers, that's like 3 different teams coming to you for free of cost, just by saving 4.5 hours in your feedback cycle and saving per pull request. That's what concurrency does it to you, right? And enable shift left, that's again part of the story. Now it not only you run it in your normal pipeline, you can even test your branches at scale, immediately know what's wrong with my code, and iterate. And when you merge your pull request, it's already production ready. So the chances of your code failing to the right side of the pipeline all the way in the production you're decreasing it. So you're not going to lose any money in production. You're reducing the chance of production issues happening because of code wise. You're reducing the chance of your code failing in the pipeline and blocking others from running, and they have to wait. So again, it's saving time and saving money in production. Visualize is, as I mentioned before, it helps you bubble up, because if you run 10, 15 times a day in your automation because you made that many changes, you don't have all the time. You can't just go to the dashboard or go and look at 15 times and see what failed. You need to have a smarter way of storing something, bubble up only the issues that matters and show you, hey, this is what the problem is. Or have some kind of trend chart that shows when something fails, aligned with what is the version of the app, Git hash version, that you know exactly where the failure is. And accelerate change is basically, things are changing, right? We have to look at, how fast, what are the new technology we can use. We can't just stick with automation. We have to also go and see, how we can use latest technology to improve the test automation infrastructure. So as I say, normally definition of our roles have changed, and challenge is to understand this and pivot. We can't just stick with automation and say like, oh, no, I'm going to just do that. But how can you how can you step up and then, brace other technologies, brace other mechanism to, make your life easier. So I think that's pretty much from my side. It is bound for disruption. I think the cross-browser SaaS platforms, because of all the problems and use cases I mentioned. But luckily there are solutions available for being cost-effective and allow you to shift left and go faster to production with quality. So that's all from me. I
Awesome.
saw there was a question.
Yeah, no, I just wanted to thank you as well for doing this. We got a couple of questions in there. we can open it up to questions. And then, yeah, I just wanted to say I was writing some notes for because I didn't even think of the reality that the company that I'm currently at, we have ads, and I don't even think of that they might be opening it within some social media browser, like say for example Facebook or something like that. That specific browser you mentioned. So I don't know if we have even test coverage there. So very, very interesting details on all of that.
Thank you. Yeah. How do you take into account localization and translation for different countries in your coverage? So, I mean, localization, I always advise teams never to check for actual strings in your automation, because that will be the worst pain for you. It'll be there for a long, long time. Because if you look at how localization works, is mostly big companies, they have a localization team, and they will keep optimizing and changing the words that to suit to attract people, on a day-to-day basis. So you can't just copy something and say it's the title is always going to be there. It's never going to be, and that's not the purpose of automation. That's not the purpose of automation, right? If you want to automate localization, go to the localization team and ask them to automate. Make sure that for say Brazil, the title is this, and in an automated way, go and attack at that lower level where the contents are created and put to a different file, which is consumed by different version of point of sales of different languages, which is picked up and showing, right? So I would say never go and check for strings of different sides. That I don't think that's a purpose of automation. There are better way of doing localization tests. But testing different point of sale, I know I've been in the situation, like for example, we might have like 30 different point of sale, but all pretty look 99% looks pretty much same. You don't if you understand the background, like how these sites work, if it is coming from the same code, then you might not need to run everything on every site, everything on every point of sale. You might need to do a quick sanity, like if you have 100 cases, you can run just one on everything, just to make sure that there's no configuration problem or something like that. But most of the cases, you don't have to run all your cases across all the point of sale. That will be a very expensive thing to do. At the same time, I don't think it's necessary to do that.
So this look like, let me check the chat. I don't think I see anything else. Yeah, I mean, some of the things that I thought about, like, aside from the social media browsers and all and whatnot, for your current organization, do you find that y'all are like testing against some of the browsers that you'd mentioned during the talk? Say, for example, like something outside of Chromium.
Yes, so we follow pretty much same approach. One browser is you test all your primary cases, pretty much your entire suite, and then you use Chrome emulator or something for your your rest of the suite. Like for example, Samsung Galaxy or iPhone X or something like that. At those breakpoints. And then we do, run small subset on real devices using some providers. Yeah.
Cool. Very cool.
Yeah. How do you take into account, or when do you take into account any of the load and performance, on your mobile or your browsers? Is that done by a different team, or is it a frequency that you build that structure into your testing strategy?
Good question. So it is done by a different team. I think now the famous tools are Google Lighthouse, web page test. I think is acquired by Cashpoint, I think. But Google Lighthouse is probably I think now everyone is using for checking, making sure your page is it gives you a score for even accessibility, how fast it is and all those things. But there are cases where you have to actually measure the performance of a page from a customer perspective. For example, if you use JMeter to test your chatbot, it'll be very difficult, because you can call the API which the chatbot is calling and make sure, hey, it is fast. But when a user types something there and it actually initializes and call the backend, and if 200 users are doing it, how do you measure it? So sometimes for those things, you can actually do it like how you do automation using Selenium Grid, and make sure and simulate those kind of thing and make sure that all that everything is working fine. But performance wise, yeah, there's a separate team that handles that.
Thank you.